Aloha and welcome to this practice WOD called Digits Model. This is pretty cool because when we're done with this, we're going to have actually implemented the model, the view, and the controller, MVC. So in some very limited sense, we'll have a fully functional web app at the conclusion of this. In some other sense, it's not functional at all, but functional is kind of a matter of perspective here. So the idea is we're going to basically make this form work in some bigger sense. So when we bring up the application, there will be no contacts. Then we'll go to the contact page, we'll type in a contact, and then lo and behold, if we go back to our home page, we should see that contact listed. And what that's going to require is creating the model, right, which is going to be a data structure that holds all the contacts in our system. It'll be an in-memory data structure, won't be persisted to disk. That makes it very simple to implement, but not that useful in general. And then we have to make once we have that model, we have to update our controllers to basically add, when it receives a form input from the user, it's going to actually add it into the model, and then we have to update this page with current contacts to actually retrieve the data from the model and print it out in this tabular form. And as you're going to see, Play makes this pretty darn simple to do, which is good news. It's pretty darn simple to do once you know how to do it. Okay, till then, it's kind of opaque. All right, so the first thing we're going to do is create a branch off our digits master. Now I will say, if I can retrieve this easily, that you should make sure that you have merged your previous WOD back into the, come up. Okay, there we go. So as you can see, we had that form 1, we had the basic WOD, the mock-up, and then we had form 1, we created a branch, we merged into master. Then we had the validation, we created a branch, we merged that into master, so we're up to master again. And we're going to start making this WOD, and this is what you should be seeing as you build these various versions, as you keep making branches and then keep merging it back into the system. Okay, so how are we going to do that? Well, we'll find our GitHub window, and it's on master, and then we'll say add, and this is supposed to be model 1, so we'll type that in. I know some of you are using the internal stuff in IntelliJ. That's all fine as long as you can use it efficiently and you're not messing up. I noticed several of you are having problems with the Git. You don't quite know what you're doing. One of the reasons I keep showing you this GUI is because for the purposes of this class, the GUI makes it very simple to use GitHub and Git in a reliable, brain dead, can't go wrong kind of way. So you can go use a more directly integrated thing of IntelliJ if you want. That's all fine. I don't think it saves you much time. And then also, if you start wanting to use GitHub with some other system other than IntelliJ, you can either go to the command line, which also has, it has more power. But again, for the stuff that we're doing, I've never needed to not use the GUI. Well, that's not true. A couple times I've had to not use the GUI, but for 90% of the time I can use the GUI, and it works just great, which is why I'm actually doing that. And I'm realizing I forgot to start my timer, so shoots. Okay, anyway, that's fixed. So we've already got our master branch called model 1. Make sure the system passes QA tests and check style. So I'll go here to the command line, and I'll say activator test. And then actually, while we're doing that, we can just basically go into IntelliJ and run check style, and you're going to notice that I'm using this custom scope, which is the default version control scope, which is, as of now, kind of the recommended way to run check style to avoid having it look at other files that aren't appropriate. We talk about that in various ways. So I'll run that, and we see no suspicious code found. We see that the tests all pass. So our system has passed QA, so we're going to implement a model for contact data. Okay, so that's going to involve a few things. The first thing is we've got to create a package. So we'll do a propeller n, and we'll hit package, and our package will be named models. Okay, you definitely want to do that. And then within the models package, we want to create a Java class, and that one is supposed to be called contact. And we'll add it to Git, and then within contact, we're going to create 3 private string fields. First name, private string, last name, and private string telephone. Okay? Having done that, we can now do some nice things with IntelliJ, such as we can select the class name, do a propeller n, and say that we want to generate the getters, just getters. We're not going to generate setters for this model object. Okay, it's kind of important to understand that, but we'll now select all 3 of those, hit return, and now we've got all of the getters for this. Go back and select contact again, do a propeller n. We're going to create the constructor. The constructor is also going to take all 3 of those arguments. Now we've got a constructor which takes the 3 arguments and initializes our object, and that's basically what we want to do. Now we don't need any getters because once we've created a contact, we have no, at least at this point in our system evolution, you can't edit a contact data once you have it. So all we do is we gather data from the user, we create the contact, and then we need to get the data out later. So there's no reason to have the setters. And in general, that was one of our design or coding standards is, don't create getters and setters just brainlessly. Only create them when and if you have the need for them. And so we're going to say this is a mock-up model for the back-end database, because this is this is going to violate all sorts of things that like basically concurrency and all sorts of stuff that we'll get to. But as a mock-up, it's going to serve as the function. So we'll say creates a contact from a contact instance, the first name, the last name, the telephone, and down here create some Java docs for that, returns first name, the first name, returns last name, the last name. These are, unfortunately, these are, I don't know, in these very trivialized kinds of data structures. What went wrong here? It's not understanding. First name, return the first name, get first name. What is wrong? Okay. Oh, jeez. Okay. All right. Sometimes just okay. Returns the last name and returns the telephone. The telephone number. Okay. There is our. And also we can kind of see, we're missing the package info file. So let's do a propeller n, go down here, package info. Again, this is just, kind of making sure that we are going to, so things are never used, and that's really okay because we're going to use them later. Okay, so we implemented model for contact data, created a simple in-memory repository for contacts. There's a bunch of different ways you can do this. The way I'm going to do it is via a contact DB class. And the idea here is that we're going to have a public static list of contacts. So we're going to basically create this singleton. Private static list of contact called contacts equals new, and then we have a option return to make that a Java util list, new array list, and having done that, we basically have two methods that we want to have with this, which is one is called a public static add contact, and for this we're going to have it, and we'll do option return to add that import. We're going to basically, public static void. We're going to have it do a contact form data because later on, when we get to actually a backend database, it's going to be convenient to have this thing get a form data instance, because that's going to make unique ID manipulation better. You don't have to do it right now. You'll just refactor it later on. But I'm going to do it this way because I know where I'm going with this. But again, you know, for the WAD, you probably won't think of that immediately as the way you want to do it. Doesn't matter at all. Don't sweat it. So what we're going to say here, though, is we'll say, however we do it, we're going to say there's a contact. And you probably want to construct this contact. So if you're not passing contact form data, you probably want to pass in the 3 strings and then construct your contact inside this class so that, I don't know, you kind of encapsulate things better. I guess you could do it either way, but that's probably the way I would do it. So we'd say new contact, and then what we want to say is form data dot first name, form data dot last name, and then form data dot telephone. And then we want to say, what we're going to do now is we're going to say contacts dot add contact. Okay, so now we have this in-memory list of contacts. If we call add contact, we're going to, with some form data, we're going to create a contact instance and add it onto that in-memory list. And the only other thing we need for our little mock-up-y type thing is a public static list of contact, get contacts. And that is going to be even worse, because what it's going to do is it's going to return, because we're just doing a mock-up, and this code will go away. I'm going to elect to just, you know, blatantly return that data structure. That's very bad practice in general, because you should, the client could then take that list and manipulate it in various ways, which would be bad. You probably want to actually, you know, clone that list if you were doing this for real. But for now, this is, I think, a reasonable way to go, as long as you're aware of the issue. So returns the list of contacts, the contact list. And then here we're going to say adds the past contact. Well, let's just say creates a contact instance from form data and adds it to internal data structure. Internal contacts DB. Form data, the form data. Talk about, you know, kind of useful Java docs. Okay, so this is a mock-up internal in-memory data structure for contacts. Okay, and if we look at our check styles now, we can see never used, never used, never used. Okay, and that's okay. Okay, so we've created a simple in-memory repository. That's good. And so now we're going to update the index validation to dynamically display all context. Define list of contacts as a parameter. Use the @for control structure to loop through them. Cool. So let's go to index.scala.html. So the first thing we want to say is this should no longer be that string. It should be contacts, which is a list, and we're going to use Scala notation to represent that thing. And then inside our table, okay, we're going to use this @for, and you can look that up in the play documentation. It's pretty simple. We're going to say @for, and then we're going to say contact, and then it has this kind of crazy syntax for @for contact in contacts, and then we'll basically do one of these, and I think that's so cool how it actually knows to indent that structure when you add the parens and everything lines up. We'll get rid of this command delete this line out of here, and then what we want to do here is substitute each of the hardwired fields with the appropriate contact info, and the way we do that is we say @contact dot, and then we see, you know, get first name. That's what we want, and apparently with Scala we don't even really need that the parens, but heck, I'm going to add them in because I'm a Java guy. So get last name, and then if we go to the telephone, we'll say @contact dot get telephone. So that's how we do that @for. Really trivial to do. Just you got to use your @ in the right way. And then we need to, so that's the @for update application.java to interact with the model. So to do that, we go here and we see, well, the first thing is that we can't pass a string here. What we have to do is pass our get contacts, all our contacts in, and it's red because we haven't compiled yet. So we'll do that in a second. And then in our new, when we post a contact, once we get to here, what we want to say is contact db dot add contact with the contact form data, which is that right there. Okay, so now let's try a propeller F9 to make the system, and let's see if IntelliJ can figure it out. I'm starting to find that sometimes IntelliJ, it will compile fine, but the red lines won't go away despite all my best efforts. So I'm getting a little frustrated. But sometimes they go away, sometimes they don't. We'll see what happens this time. This time they don't go away because we actually have an error. Okay. Oh, and so in our test class, let's go to here. We've got this index.render, and there what we need to do is pass in a list of contacts. So we should be able to say contact db dot get contacts. So let's try to make again. And see what we get. Okay, so compilation completed, but as happened to me when I was playing around with this, I still get this red line argument, which is quite frustrating. And in fact, if we go to application, we're seeing that it doesn't understand this. Now, I'll try something here, which worked for me before, just to experiment to see if it works for me again. Everything's saved, so what I'm going to do is I'm basically going to quit from IntelliJ IDEA, and then I'm going to open recent again and just see if that fixes it. It fixed it. Okay, so that's pretty frustrating, that you got to do that may or may not work. But anyway, it did compile, right? So we didn't get any compiler errors. So somewhere inside IntelliJ, it understands that things are cool. It's just that syntax highlighting thing that's not working right. That's just crazy. Okay, so we've compiled everything, but does it work right? Who knows? Let's find out. So to do that, we say activator run. And then let's just scroll up here and put this down here. And then we can go to localhost 9000. So we current no contacts left, that's good. We'll go to new contact, we'll say Philip Johnson 808 956 3489. Add. Got data, that's pretty good. We go back to home, and there we do. So we have it. Let's make sure this passes Q again. So we'll do propeller shift I, check style, custom scope of default, so it's only looking at our version controlled files. We'll say OK. Does the analysis. No suspicious code found. That's great. You can do a control D to get out of here. Do activator test. See if our tests still pass. Our tests aren't doing very much right now, I have to say, but very soon they're going to actually do things. In fact, now they could really do things, but we haven't learned about the framework we'll be using for testing a working web app. So that'll come in the next module. And we see that all our test passed. So the only last thing we need to do is basically commit our branch. So go back to changes and finished the digits model wad. And we can see we've added 3 new classes, made some updates. Looks great. So we're going to call that 18 minutes for this WAD. Hope you enjoyed it. We're really starting to get a little, play a little application here that does something. That's pretty cool. Have a good weekend, if this is the weekend for you.